go ahead and turn this down a little bit. Can I bump it to 50? Yeah. A little down like that. Can do that. Alrighty. Let's get this going a little bit. Actually, hold on a second. Let me look here. Back to the channel real quick. I want to send this out. Okay, here we go. Alright. Gonna implement these cameras. Alright, let's go ahead and put that on. Alright, cool. I'm probably gonna lower this just a little bit. Okay, that should be better. All right. So today we're continuing where we left off the other day with cameras. Gonna have the cameras following the character and I assume transitions. And this is 1 out of 11 of this. So I'm sure there's gonna be a lot of material to cover. Actually. Alrighty. So let's kind of have to review a little bit what we did the last time. So right here, as you can see, this area is set up in our configuration. How we have the width and the height. And then up here where we have our camera, we put it right here. We set the bounds, the world for the game state.width and the game state.height, which if we go to the game state, where are you? I hate having everything so disorganized, but this is how they set it up. Where is... Okay, where the heck did they throw the game state at? Oh, is that down here? There it is. There's the game state down here. So for the width, they have the 2000. Okay. So they have a 2000 pixel width with a 600 height. So you're not going to see this, but this is what the camera's going to know, is that the width of it is 2000. And so it's going to say this is the bounds right here of the camera. So it can go all the way for the width to 2000 and then the height 600. And then it's going to set also the world to be 600, 6000, or 2000 and 600. So this right here is going to keep our constraints. And then as we move along, we're going to have this, the camera, follow us, but we're not going to have it like exactly perfect. It's going to trail behind kind of at a fast pace, kind of not. So watch as we start going. So it's not exactly centered, it's very close though. So it goes all the way until the camera hits 2000 pixels, and then the bounds of the world for 2000 pixels, you know, it stops us. So that's why you see the physics world setting the bounds on here. And then you have the cameras, the main, and setting those bounds. And then we have it following. And then it'll also follow us backwards as well. So that's what we kind of picked up on the last, at the end of the last video. We just kind of got a brief introduction of kind of where this falls on. So let's go ahead and just kind of jump into the second one, see what's next. Okay, so now we want to add the we gotta add the platforms. Okay, so we'll create a side-scrolling platform. We better make some platforms for the player to jump on, right? Create a stat group for our platforms as before, but how we decide where to place these platforms. And this is a design choice, but we can at least make the design easier to accomplish by parsing out X and Y coordinates and placing our platforms on a grid. So, function called create platform. So if we go through here, create platform, okay. It takes the X index and a Y index to create our platforms. Locate the level setup method, add in a call this.create platform within the for loop to add platforms to our game. Okay, so if the type of X or Y index equals a number, and this is an AND operator, so this condition has to and this condition both have to match, or they have to both be true in order for this to execute. So if the Y index is a number and the X index is a number, it will actually create the platform at 220 times the X index. So it'll be like around here, and then times wherever the X index is going to be, and then looks like creates it on the Y index times 70. So 220 times the X index, and then Y times 70. So this way. So, okay. And then setting the origin to 0 and not 0.5. And refresh body. Okay. Refresh body. I wonder what that would be. Anyway. So, we're gonna scroll down here into the level setup method and add the call this dot create platform within the for loop to add platforms to our game. So for it's gonna take the x index and the y index, okay, of height entries. This dot heights and dot entries. So the heights 4 and 5. Okay. Where did that? Okay. So we can create the this dot this, basically saying that this right here, or the level, or whichever this is going to be called upon, will create, call the create platform event. That's what it looks like. Okay. Use the x index and y index variables created by looping over this dot heights as arguments. So in here, so it's taking, okay, so it needs the x index and the y index. So it's going to take the x index and then the y index as arguments. And it's going to create the platform, giving this x and this y. All right. So the index. Okay. So these are the arguments in here. So this basically says whatever the number in here and in here, it's going to add this to here and this to here. So the type of y index, which is this right here, this argument, has to equal number and this has to equal number to create this. And if it doesn't, then it won't create if the value that's inputted isn't a number. So, all right. So we're still following. Still probably set at 2000, I believe. Which is pretty cool. Okay. So it creates a constant. So it can't be changed. This dot heights dot entries. So what is the entries? Kind of trying to figure out where that entry comes in. Because if you come down here and go to the game state, there's nothing here. This dot height. Oh wait, where is it at? This dot height. No, not that one. Heights. Dot entries. Huh. Ah, there we go. This dot heights. And then entries. So that would say the entries within the heights? Or is that another? Hold on, let's see if we can search it. Okay, so there's only one. So this entries has to be everything that's the value of heights. So 4 and 5. So it basically takes a 4 and a 5, because those are the only two entries that are inside of it. Okay. But why is there... Huh. So it's going to create this X, Y. And there are... So there's only two entries. So this heights right here is calling again right here and saying these inside here with the variable that's created. So we'll go into here and then it'll find the entry. So this is the first entry, 4, 5. So it would put those in here. I would believe it's 4 or 5. So does it just create one on the x-axis and one on the y, or? No, because this is the x, this is the y. He'll probably tell us more on. Wants to separate out the code creating the levels from the code that places all the platforms. Takes an index, y index to create platforms, locate the dot level setup method and call it in a... Yeah, we already did all that. So yeah, not too much elaboration. We'll just have to see. Now that we have a system for specifying what platforms should be in each level, we can create multiple levels. Each level is going to inherit from our customized level class, which this is right here. So this all is under the level class, it appears. And so we have a level right here, so that's the name of it. So we'll create another class that's going to inherit. So okay, so we will do a class, name it level 1. How do you do that? Or how was that added in there? Yeah. Oh. See, it's all case sensitive. So class level 1. So is that an extend? Extends, or is there an... Nah, there's no inherit, so extends level, or would that be phaser dot level from level? Okay. And then give one like constructor. So constructor. So super Oh. Okay. So it uses level 1. So it adds it onto here. And this dot heights equals as an array, so class inherits from level. Okay, so it's not phaser. So we only did the phaser right here because it's inheriting or extending to the scene class. So we already have this. So now that we have all of this in here, instead of writing all this code again, we can just do this to inherit all that stuff. Okay. So level 1A. So how did they do that with the first one, adding the constructor for here? Yeah. So they did, wait. Did I add the, I did not, the parentheses. There we go. I knew I had done that, right? Nope. There we go. Okay, so this is blank. Change the property of scene and are configured to point to level 1 instead of level. Okay, so we can do that. So it's extending. Alright, so we have everything. It's just we don't have the platforms. Okay. Oh. Okay. So that looks good. So we made a new level here. It's pretty neat. So let's go with next on this. Alright. So shaking the camera. Okay, so adding a camera shake is an indispensable effect in the modern video game, hints to the player that something jarring is rising is happening. Okay, so we all understand that. So just call the dot shake method on the camera and take the following arguments. So the duration, how long it's going to be, the intensity, how strong, force, or whether or not to start the effect from the beginning if it has already started. Callback, the function to call each frame while the shake is happening, which accepts 2 arguments, a reference to the camera and then a duration from 0 to 1. Context, the context for the previous function. Default to the scene. So you can see it's the first 2, so the duration is 100, and then the intensity is a 0.8. So that's what this will look like. Alright. So I assume. So we have the class key, and then it makes a constructor. Okay. So this is the whole thing right here. But So from here to here, constructor key, super key, this dot level key equals key. Okay. This dot next level, level 1, level 2, level 2, level 3, level 3 to level 4. Okay, so it's setting default constructors. Okay. Okay, so will the shake command, will shake the main camera vigorously, so that command up here will shake the main camera fairly vigorously for 100 milliseconds, whereas this command, so we have 200, so going by this, duration is 200, intensity, force, which would be true, start the effect from the beginning if it has already started, so it's going to keep doing it. So the function, which is the camera and the progress, so if the progress, the duration, progress is 0.5, player set tint of the player this much. So it will likely shake the camera for 200 milliseconds. Halfway through the shake completion, it will turn it to red. Force. Okay. So the progress. So if the progress, alright, is already halfway from this duration, then it will send it to, okay. With space to the world, alright. Okay. More space to the world, and this physics world set bounds. So set bounds. Ah. So it's adding the height plus the game state dot player's height. So it's adding it a little higher based on where the player is at. Okay. So to make it so that there's one Cody length beneath the world we see that the camera won't pan to, we want to make this our death plane. If the player falls below there, it means they've lost. Let's check if the player has fallen down inside the update method of our generic level layout. Okay. So this does our velocity, animation, plays. If the game player is touching down, plays the animation, and it does this. So let's add the camera shake. So we'll do, okay, so if the game state dot player dot y is greater than the game state dot height, remember, you go negative when you go higher, you go positive when you go down. So if it's greater than this, then we'll do a camera. So camera dot, that wouldn't be, okay. So this dot camera main dot shake. Okay, and then we need the arguments. So the duration will be 240. A very subtle shake, so it won't be a violent shake to us. False. So it won't just keep going. See anything at all? And then the function, and we're gonna call the camera and progress. Okay. There we go. Make that a little better. And I'll put a semicolon at the end of that. Say we're done that. And okay, so what are we gonna add the logic? So we want to restart the level after the shake is completed. Okay. So if the progress is greater than 0.9, then we will get the this dot scene dot restart this dot level key. Okay. So if the player's Y position, the Y position is greater than the levels right here, then this dot scene dot we will shake the camera, and then we will, once it's done shaking, it'll get the Cody will revive. So I gotta look. So the level key is key. Structures key. Okay. So we can go ahead and run this. So if we fall, so we fell, it seems like, yeah, there we go. We had done something wrong somewhere. This dot cameras. There we go. It's usually these small things. So we'll go ahead and put this back where it belongs up here. Let's go ahead and run this. It's the little things. There we go, see? And that indicates, oh, done something you weren't supposed to. There we go. And then it restarts the level. The level key. That's right here. Okay, so the key is the level we're currently on, and then we've assigned it to level key. Alright, so the key right here is the super, which gets stored in here in the scene. As the scene, And then this is the current, so whenever we need to, we can restart and then do the level key. Okay. Whew. Okay. Do this. Oh no! That's pretty neat. Alright. So we got that down. What is the next thing we go? Fading out. Okay. Fading out of seems like a fitting transition. Kind of like Mario games. How you fade in and out. So, fading out of a scene seems like a fitting transition. A cue taken from the film industry, fade out offers a much softer effect than the shake, but it's as concise and phaser. So just the dot fade method is a camera method that takes the following arguments: duration of the fade. Alright. The red, green, and blue, so RGB. You have the force. Starts to fade out over if it's been already started. So we want that to not be like, if you want it to be continuously fading out, we'd use the force for true or false. Callback, which would be excuse me, callback to use during the fade out effect, and then our context used for callback function. Faults to the scene the camera is in. So, for example, so we have the this.cameras.main.fade transition RGB. So I believe if you add all these, can't tell. I think that might be white. Have to see. False, so it's not going to keep repeating. Function, obviously the camera and the progress as the arguments. If the progress is greater than half, then it'll say the player's x position will equal 5. From the left edge of the game, right? So it gets moved, over here. So in order to transition from one level to another, we need something to indicate the end of the level. Use a video game staple, the bonfire. What we need to do is add a new bonfire sprite to our physics engine. Then when Cody interacts with the bonfire, we fade out the level and put Cody in the new one. Within level setup, we've created our bonfire and started creating an overlap function for it. Okay. So there's the level setup. There's a for loop to creating the platforms. I kind of want to take a look at that height. Actually, that'd be down here. So here are the heights. So does this just go 4, 4, 7, 7, 5, 5 for the X and Y? But yeah, it changes the super here. Okay. But yeah, this.heights, it adds different heights for each one. It's okay. Anyway, sorry, a little sidetracked. So, whenever we're adding this campfire sprite at the game width, but 40 pixels over from the end, and then at 100, so on the Y, and then using the campfire, and then this.physics add overlap, so it can overlap, so the game player can go to the goal, and then the function. Okay, so all right, so we'll do this dot cameras dot main dot fade. So once we overlap with the goal, we want to then go ahead and make a fade from the camera. So it wants the duration to be 800 milliseconds, 0, 0, and 0. We don't want this to repeat. And then the function should be the camera and the progress. Okay. I think so if the progress is greater than 0.9, so at the end of the loop, we want to go ahead start the next scene. So this dot scene dot start, and then okay, so now we got this. It'll start the next scene, but we gotta specify. So this dot next level, and then see, now we're going to next level, but we have this right here. So we gotta call this not level, and then use this dot level key. This dot level key. Key, and then puts it in here, so it can be this one, this one, this one. Okay. Level key. All right. So let's go ahead and try that out. So we go all the way. Oh, all right, cool. Almost there. Now see? Yeah. So 0, 0, 0. The RGB indicates black. So, oh, and see it has even the shake. Oh. All right. Cool. There we go. There we go. Now, if we want to make this a really long, we can make this 5 seconds long. Okay. 1, 2, 3, 4, 5. See? Like, if you get to like the end and you want to make like kind of a dramatic effect at the end for like a scene, you can go ahead and make this 5 seconds, which is pretty cool. So, mind you, I will say when we start actually developing our own level, there is an extremely large amount of material we're learning here. So, the only way we can actually make our levels is if, we practice and practice and practice and like actually start doing it ourselves. So this gives us the groundwork. It kind of tries to put in, our memory, which is why you have the quizzes and you have your projects at the end. But, we don't technically have those projects. So we're just going to make kind of like the big project at the end. And we're at 5 out of 11. Okay. Alright. I'll look on real quick. Okay. So we got a few people following, which I appreciate. You guys kind of sticking along. I wonder who's all here. Got my wife looking at me over here. What's up? Okay. So we're good on here. Let's go to 6. So parallax scrolling. Create an illusion of depth in our frozen tundra world using something called parallax effect. Okay. Refers to an observable real-world phenomenon that things closer to us move faster than things further from us. A full moon or a faraway mountain may not appear to move much at all as you drive down a highway on a clear night, but it's simply so far away that the movement is occurring very slowly. By comparison, a hedge of trees against a road or a neon light for a roadside shop will whiz by. So in order to simulate this motion, we can create 3 different background layers of different sizes. Why do they need to be different sizes? Since we'll be scrolling some of our near layers very fast and some of our farther layers very slow. Alright, I know where this one's at. Okay. So we're going to start making building blocks and making things actually go faster in the foreground, but slower as it gets farther back. So that's pretty cool. So let's look for this method that got created. It's called the create parallax background that they created for us. All right. Add 3 background images here and set their origin. So this dot add dot image and we don't even have to do that because it already has it for us. So the game state three stacked backgrounds. Well, first, hold on a second. Let me see, are these actually in here? So there's the mountain, BG1, BG2, and BG3. Okay, that's what I was looking for. So we'll do BG1. Okay. With the... it'd be game state.bg1. Oh no, it's... What? So... let's add the origin first. And we want the origin to be at 0. Okay, so if we add the image, so okay, we're all right. So we have the BG one. Oh, all right. That's what it was doing. Okay, so game state dot bg1 will be this. Okay, that's where I was getting like the confusion. So image bg1. Set origin, and we want the origin to be 0, 0, and use the BG1. Okay, and saying the origin at 0, 0, so it's resetting it. So reset the origin right here. Okay, so let's create the game state for BG2 and game state for .bg3. So this dot add dot image. So we'll put this also here. Put this at a bg2 dot set origin 0, 0. And we'll do, I could have copy paste this and just, you know, make it easier on myself, but you know. Sometimes typing it out makes it easier. So we'll do BG3, set the origin at 0, 0. So we're gonna reset that. There we go. We now have our images inside here. So once I hit run, they should appear in the background. Damn big sexy with glasses. You know it. So out here making game. Trying to get everything to run the way it's supposed to. Hey, there we go. So when we start moving, as you can see, everything's moving right here at once. So I assume they want us to over time, they want this foreground to move slow, like kind of fast, this one to move pretty slow, and this one to move kind of in between. Let's get to the end here. Yep, and then it goes to the next scene. All right, so now we have these. We're doing pretty well. I mean, this is actually starting to look like a actual game. Even though like how basic it is, once we start adding enemies and doing that stuff, I'm sure it's going to come in here at some point. And we'll have to put in tweens and stuff. Alright. So determining the scroll factor. In order to accomplish this effect, we'll upgrade the scroll factor of each of our background layers. Okay. How fast an object scrolls with respect to our cameras. So all of them have a set factor to 1, so that means like when we're going, they all move kind of the exact same. But we can do a dot set scroll factor. So here's the formula. We have the window width, which is the configuration dot width, which would be 2000. You have the game, or no, that would be 450. This is 450 from here. The game width is 2000. Then you have the width of the background is going to equal the game state of the background getting the bounds, and then the width. Some background scroll factor will equal so the background width is going to subtract from the window width. So it's going to take this window and subtract from this the bounds of the background. And then it's going to divide that by the game width subtracted by the window width. Okay. And it's going to find the difference between those. And then game state dot uses the scroll factor. So it's going to set the sum background width equal to, oh, this is the scroll factor. Okay, so this is the speed. So it's going to do the game state, the background, which would be BG1, BG2, and BG3. Set the scroll factor, and then use this variable in here in order to do what we want it to. So if we wanted to use this for others, we can. So we'll scroll down here. At the end of the parallax background, setting the scroll factor for background 1, background 2, and background 3. So now they want us to do this and use the formula that we have already done. Okay. Oh, so it's already done it. We did the origins right here, adding the images, and did the dot set origins, but they added it right here. So they put it on separate lines. So we did the game width, okay, which would be they're parsing as a float. So a float number is like adding like kind of a decimal, like 0.0, instead of like a whole number. So you have like, it's taking this and putting it into a float. So game state, background 3, getting the bounds, dot width. Okay. So it's getting the boundaries of background 3. I kind of want to see where that comes into play, that get bound. No. Okay. So it's taking this and just getting the bounds, I guess, boundaries of this. So this is just like a method itself to utilize in the library. Okay. So we didn't have to declare it as a function in here. Like in this, it's already made from when, from Phaser itself on an object. Okay, so gets the bounds, finds the width. So anyway, gets the width of that. Game state.width is going to be the game width, which is right here. So we're basically storing this, and then we're gonna store it inside this variable inside the game state width. I know it's confusing, but this is the width of pretty much the game. So we're putting that in here, and then we're getting the window width, so we get to configure the config.width. Oh, okay. So originally that game.width, if we come down here, so it's not even in here anymore, where it was 2000. We did have width of 2000, height of 600, but now we're getting rid of those, and now we're setting an actual customizable width of the actual game screen based on the background is what it looks like. So it's getting 3 get bounds dot width. So it's getting the boundaries of the background 3, which would probably be this mountain right here. So it's finding the width of that, and it's extending it all the way down there. So in the game width, and then the window width will be configuration width. Okay. I see what's happening. So now we're storing the background 1 width, getting the bounds width of background 1, background 2, and background 3. And we're going to add a scroll factor for that. So we've now established this. So let's go ahead and, so we can make a const. Let's name this. Okay, so we can make this anything that we want. Scroll factor, or no, we can make this background scroll factor. Okay. So since each of them is going to be different, that's why we have this formula. So we want to take, we want to get the, oh, do we have to do a scroll factor for each? Oh, so we gotta make one for each. So let's do the first. BG1 scroll factor. Okay. So we'll do background. Ooh. Some background width. So we want the background 1 width. BG1 width and subtracting the window width. So, okay. Window width. All right. And then divide that by the game width. Or is it, or is it game state dot width? We'll do the game state. Yeah, dot width minus subtracted by the window width. Okay. So that's done. Then we'll go ahead and do the game state dot BG1 dot set scroll factor. Wait. Okay, so we can do the scroll factor of BG1 scroll factor. So we'll do this for each one of them. All right. Then we have one for each of here. Cool. So we'll just change these to 2 and then 3. So we don't have to keep writing those. And then we want to change this to 2, this to 3. And then, so let's change this to 2 and this to 3. So we're setting the scroll factor on each one of these. 2, see the scroll factor for the background image? Or did you set the scroll factor? Yeah, sure did. You're seeing that, right? I mean, clearly, that is moving. Oh. Did I put that there? Yeah, so that was just a mistype. It's still... Alright. So it's still moving. So that is the formula. So if you ever have like a foreground, a midground, and a background, it's right there. Now, if you want, you can actually comment these out and you can look at them like, you can just look and see what they look like on the screen. So this is your first, and then you have your second, what that would look like. Let's bring the second. So that was your first one, and then look, see, the second background you just have regular trees, nothing actual fancy, and then for the third, you actually have your foreground. And I ended up bringing up the developer tools from my fat fingers. Then look, now you have the foreground. So those are set, and not exactly sure why that's failing me. Background 1 and background 2 with the formula. I have given you the formula. Okay, so I'm gonna look at this solution real quick. I'm gonna see why in these right here why doesn't that equal what we should? So what are we missing from that? So when we scroll down here, okay. This is my code. Okay, so I put extra. Oh boy, come on. So what? Where did that go? What are you doing to me? Show, okay. Show the difference. I don't know why that decided to do that. Okay. So I didn't have to write this whole thing out. I could have just done this and just went ahead and put these inside there. So essentially I did the right thing. It's just wow. Okay. I just put it into a separate variable instead of just doing it directly. So look, see, I can easily just take these right here for background 2. Instead of, you know, this, just put this here. And then instead of it being in here, we can take that and put that in here. And this variable, these Don't need these variables. Alrighty. What? What the hell was that? What? What? Wait. I'm just trying to figure this out. Oh. Uh-huh. Because it goes around these, and then this one goes around these. So you need those parentheses in there to go around this and around this. Or else it combines everything. Yeah. So let's go ahead and put these around there. So you learn from math class, you know, you take everything that's inside here and do these first, and then you PEMDAS. You know. Now let's go ahead and run it. We're gonna get it. It's moving there, and it's working now. I mean, at least it's not zooming like it did the last time. Let's look at that solution again. Is it because I have the game state? No. Oh, that's where we went wrong. See, it's using the game width, and I'm using the game state dot width. So it's doing the exact same thing. I just called that instead of what it wants me to. So in order for us to continue, we'll just please it by doing the game width instead. Which I guess, I don't know if consistency in this context is really needed, but it makes the game happy. So, see, it does the exact same thing. No difference. And that is parallax scrolling. So, you have the width of the background subtracted by the window width, and then divided by the game width subtracted by the window width. Well, first you subtract this, and then you divide that, and that's what gives you your scroll factor for each. And then your game width is based on the background 3 here, and you're getting the boundaries of this. Okay. I'm not exactly sure what these backgrounds are, because you have the images right here. So, I mean, you could, you know, look it up in here and just see the width of each one of these PNG files. So, see how this is smaller? That's why it goes. That's why you can just create like a small image right here and it'll take longer to get to the end based on the width of your foreground. So you have this right here. Okay. You have your trees, and then you have your last one, which is significantly. So you can see right here, 600 by 2,000 pixels, 13,000, then 600. So one big thing you have to note is the way it's looking is you have your foreground, and then it gets this background, which is 2,000, and then the game width is 2,000. So we'll come down here. Bounds width. So it gets the width of background 3 and sets that as the game. So that is your actually overall game width for here. It basically sets it on this image like, hey, this is how wide it is. That's how big your level is going to be. And so that sets the standard for that. So you'll have your background width, and then you subtract this window right here, and then you have, this, and then, the scroll factor. So that's why, even though this is a smaller image by far, this is 600 back here. This is, this is 450 right here. It only hangs like, a little bit over. So it's not very, very long. But whenever you're scrolling here, it seems like it's way longer than it is. And that's because it basically goes off of the front, this right here. And depending like where I'm at on here, it scrolls slower or faster depending on, everything based on the level of the front. So this goes the fastest because this is your main level. This goes a bit slower because it's smaller, and this goes the slowest because in the background. So that's your panoramic parallax backgrounds. So cool. We now have that done. What next do we have? Changing the weather. If a long journey goes on for several days, how we communicate the length of the folks playing our game. Okay. Use a few strategies to add the concepts of ambiance, lighting, time of day, and weather to our game to make these same assets feel like the world they're part of turns and changes like our own. So, I would say that's like Terraria. If anyone's been played Terraria, when you go to certain bounds of your game, like once it hits a certain point, it then makes that transition. So I think that's what it's describing. So the sky's color is the easiest things for us to change by changing the background color of the game. Since we actually want to update the color of the sky multiple times with our single game, we can make a new background. A rectangle with the same dimensions as our canvas. Be able to update the color of our new background with the appropriate color of the sky. Okay, so it's going to become the sky. So the first one. So we want to create a background color. So this dot add dot rectangle, and we want this to be the width of our screen. So saying the origin at 0, 0, and then of the rectangle, and then the width will be the width of our window right here, the config width, and then config height. Okay. 0, 0. So this essentially puts one right here, puts it at the bottom, and then I would assume these right here. Well, actually, this one puts this one, yeah, and this down here, this one over here. Or, let me think. Yeah, so this here, and then I believe this one. Height. I'd have to look at the rectangle exactly. So let's look at our documentation real quick. Let's this dot add dot rectangle phaser 3. So we have looked at this before, it looks like. XY position, the width and height. Okay. Yep. So this is the X and Y position is at 0, 0. And then, oh, here we go. So 0, 0. And then the width being this, and then the height of here. So this is the positions. This is the width and height. Okay, for scaling. And then, all right. And then we have the color. So they're wanting to set this as this hexadecimal. Okay. I think that's it. And then setting the origin at here. Nope. Of course. Set origin to center it. Okay. Okay. So it wanted to store it. So game state, obviously, because we'll have to probably update this later. So BG color. There we go. Run that. Yeah, because we want to put this in the game state, so later we can change the background color. So they created a set weather as well. And that is in the set weather. Okay, so when we call the set weather, we can choose what weather it wants to be. Okay. So inside, after checking if weather exists, so in here, so if weather is true, like if there is one in here, so it creates this variable, the background color, and then so it wants us to, I know the fill color, but so it's gonna let the background BG color equal weather's weather. Oh, okay. Oh, okay. So it's storing the background color in here to the weather. Okay. So it's going to weathers for here, and then it is going to set it to morning, afternoon, twilight, night based on the background color, it looks like. Or storing that background color. So it's going to do the... Okay, so game state, yeah, you'll see what I mean. So game state dot bg color dot fill color. So it's taking the BG color that we created up there. I'm not going to scroll all the way back up there, but right here, and then we're going to alter the fill color and set that to equal to the BG color that we defined right here. Okay. So if there is a weather and it exists, it's going to set the background color, this variable right here, of background color. Okay. So this, okay, to weather. Weathers. So weathers in here and get the weather. Okay, so this is an accessor. Okay, so basically it's creating the let, making this variable based on this background color value. And it's making it, this value, its own. It's going to weathers. And it's getting the weather right here of this. So it's getting this morning. It's background color of morning. So these are all the morning right here, the first value. And then it's accessing in here for this, which is this. Yep. So it's taking this, whatever which one it gets. Alright, I need to think real quick. Weather. So it's getting the weather. So this is a variable. And it's saying this background color that we created up there, which we set this, is it's altering the fill color to make it this right here, which is based on these. So this is an accessor. It's getting the BG color of this. So if... Okay, so it's actually indicating if this exists right here, like if it's true. So it has this one. This is within weathers. So okay. It does weathers. So all this is underneath weathers. It seems. What is this under? No? Okay. So it wasn't. What the hell? Okay, so this is all underneath this variable or this object called weathers. And then this is an accessor, which is this. So if this weather is true, like right here, it's saying if this is true, then we're gonna let the background color equal weathers right here, which is this, and then getting an access here value of this. Okay. So in order for this to take effect, we need to add weather information to our levels. Find where we define level 1, and inside the constructor set this.weather to afternoon. So, okay. Okay. Oh, come on, man. So it sets this to afternoon. Okay. So level 1, it makes it afternoon, and then on level 2, weather will be set to twilight. Okay, so that makes more sense. So this, we're now saying that this, the level 2's weather is going to be twilight. And then when we call weather, it's gonna look all the way up here. Well, we gotta look, create animations, backgrounds, level setup, set weather. We did that. Does it not want it like that? Okay. Set weather to... Because that was the function that we called. So we define level 1 here. Oh, wait a minute. We're setting it. We're not actually calling the method. So we're gonna go ahead and do this instead. Okay. Yes, there we go. So in the constructor, we're just adding... Okay, so it's basically saying that this weather is going to be twilight, this weather is going to be afternoon. Like these heights. And then we're going to call them later. So these are constructors. These are just pretty much set objects in here. Or set methods. Or values for level 2. Or level 1. And then we're going to probably call this later. Alright, so we'll go to the next one. So when we do that, we're going to change the lighting using tint. So in the set weather that we did, that we made. We gotta find this real quick. Set weather. So if you can see in the level setup, this dot set weather equals this dot weather. Okay. So let's apply that tint. We've given each time of day a tint color. Let's apply that tint to all our game objects. Okay. So we have, all right. Set tint for all the game objects here. So we want the game state dot bg bg1 dot set tint. And then we have the game state. Okay. Dot bg2 dot set tint. And we're gonna do the same for 3. Game state dot bg3 dot set the tint. Now, what does it want us to use? Let's update Cody's tint 2. Let's set the tint. So game state dot player dot set tint, and it's also wanting us to do all right. Let's do the platforms. So iterate over the platforms with a for loop. Well, let's go ahead and see what this looks like. Okay. Oh, argument color. There we go. Needs the color. Okay. Say player. Do the platforms. So we got to do a for loop. So for, let's do a, do we want to do a let or const? So let's make a constant. Platform. Would that be in? Or actually, now I gotta see what if the for loop was. Of. It's of. Of. Well, what the heck? Oh, did I went past it. Okay. So of state dot platforms dot get children. So we call the get children because everything that is within that group of platforms is a child. So the parent is the actual platforms group, but you have to get all the children inside of it. So inside there, in each one of those, we'll do a platform dot set tint, and then use color as an argument. We'll see what happens. I believe that's right. Okay. So there we go. Hooey. All right. So now that those are all completely done. So now we have a tint color for each one of them with the argument color. So does it mean when it goes to bending, it's going to just draw a tint and it's going to be twilight? Okay. So now we got to add particles. So, again, snow. Game world, we assume it falls from the sky, but how? A particle emitter. Particle emitters creates a pool of particles, a small repeated sprite, and the pool is a collection of these particles collected for reuse. Constantly dropping new snowflakes, we will move the snowflakes that we have dropped already to the top of the screen and drop them down again in the crate. So, so I would assume snowflake. So this is what we're going to use to drop. Is this little tiny little bit right here. Very small. But that's going to drop all. We're going to make a ton of those. So we'll go ahead and do the snowflake. I believe that would be in the somewhere in the create is what it said. Marble. So creating the emitter. Particles, create emitter. Alright. So the X is 0 and the max 200, so it's going to spawn these from 0 all the way to 200. And then the Y will start at 0. Lifespan will be 200, so it's going to last about 2 seconds at speed of 10 pixels to max of 200. Scale it down by 2, quantity 10, and add as a blend mode, so it kind of blends in with the background. So it emits the marble asset we've preloaded. It creates the particles at the top of the screen and pushes them down screen. It creates these marbles at X coordinates between 0 and 200 and gives them variable speeds as they fall down the screen. So we already have a create snow method. So is there going to be a... There we go. See? They got all these level setups and all this kind of stuff, and they added them all into the create, so it's not all in there anymore. So they've cleaned this up quite a bit. Yeah. So this looks a lot better. So this is what more I'm used to is, you know, now they've cleaned up everything. They've added all these, they added all the functions to their own at the bottom here. Configuration, game state, all your level scenes. Okay. So, well, we just have to go back to the snow. So where? Okay. Color, leathers. Alright. Oh, okay. Well, where is that? Some weathers. Where is the snow? So if you can't find it, we'll just go ahead and do a find, and we'll just go create snow. Okay, and then where is this declared at? There we go. So this is only available. No, it's not. It's at the very top, so it's still gonna extend to every level. Okay, so we will. Oh boy. So in here, I'm gonna add in our particles. So the game state dot particles equal to this dot add dot, I believe, image. Oh, particles. So particles, and then snowflake. Cool. Alright, so we'll run that, see if it's good. Alright. And then we'll make the emitter. So, create the emitter by calling create emitter with the following object to making it snow. it does go a little fast or a little slower. So I can make this and just go to 50. Well, actually, is that just how far it comes? If I went 5 seconds? So yeah, you can go ahead and play around with it a lot, you know, see which works best for you. But yeah, right here, the minimum is 200, max is 200, so it's always gonna go 200, the speed. But if you want it to be mixed up, you can go like 50 to a max of, you know, 200. So some of them are gonna fall slowly, some of them are gonna fall quicker. So if we do 200, max 400. So see, and it's blend mode, so it goes over your character. So it doesn't actually like get in your way. That's a lot of snow. Ah, we've also added that the lifespan is gonna be 2,000 or 5,000. So see, now it starts disappearing and getting smaller at the bottom. So it's not as bad. Alright, so one more thing. I'm gonna add a scroll factor. So yes, so so it just kinda, it doesn't actually go with you. Scroll factor with our emitter by calling the scroll factor with a 0 as an argument. Okay. So adding wind. So where was that? This part of the code to set wind the amount of snow. Setting the scroll factor of our emitter by calling. So game state dot emitter dot set scroll factor with 0 as an argument. Okay. So it kind of still goes with us. Ah, and there you go. See, it gives us that tint whenever we do this. So how we add that tint and went to Twilight. There you go. And it just keeps tinting each level we go down. So it sets this tint right here to argument of color. Color, snow, wind. So wet. Emitter, scroll factor 0. So let platform, all of the platforms be tint, alright. So this just returns nothing. Snow, wind, Snow, wind. Okay, so let's go to the next one. I wonder what that next one does for us. Ah, this is the credits. Okay. So, camera special camera effects, fade out and shake, particle emitters, tinted sprites, and parallax scrolling. So after the 4th level, they actually added the credits scene, which is pretty cool. So, let's see where they threw that. Super credits. Those credits extend super credits. Okay. Ah, so it has a whole kind of thing they've set up here. Okay, so let's try this out. Ah, see? Scroll. They've actually changed this. So, if you notice, the weather is not as bad. So let's go all the way to the top real quick. Where did they add the create snow? So here's the create snow, particle emitters. Here, add, okay. 200. Okay. Okay, we'll just continue going. But definitely looking at this, you do the color, but you also have the snow and wind. And that's within weather. So this has to be part of snow, wind, sets all this. Ah, here we go. So the emitter.set quantity is for snow, and the speed X, to set the speed X, is to wind. So based on the level, it's actually going to get these values. So basically it's getting all of these values from here and getting the values of this. So this stands for this, and then this is the accessor right here. So the color is here. You have your all these for color. And then you have the fill color saying the BG color, saying the quantity of snow and wind, player color, game state, get children. Okay. All right. So let's go ahead and finish this up. Here we go. Now it's a little faster. Down here. There. So I think this is 4. I know I probably have to. And then you have the credits. There you go. Cameras and effects. Skip for now. All right. And we have done it. That is now everything you need to learn how to create a game. That's awesome. So now we get to actually start on the development of our game. And I know there won't be a lot of rushing in there. There'll be a lot more interactions. I can actually talk to people and like do a lot of stuff because I can actually go at my own pace on that, which is going to be a lot more flexible. I've been trying to get through each one of these lessons and go in there, but now should be able to create the game. But before I think we actually start playing the game, like I think it would be wise to actually start learning how to do the sprites and being able to create our own sprites for our levels and use our own objects for a game. Just kind of small things. I think that would be good. Yeah, because I don't want to use other people's sprites. Other than my own. Because I don't want to stream with them and then just say, here, these are mine. I think I had purchased a decent amount of sprites at one point that were like 2D models. So, but I think it'd be good to actually go ahead and start working actually with making kind of our sprites, so that way we can, when we start developing our level, we can actually have like a player, we can have enemies, we can do like, you know, kind of simple backgrounds and that we can kind of play with, and just, you know, kind of have fun with it. So I know there's been a lot of learning up to this point, but now we can actually start enjoying stuff, and we can actually start doing the big portions of like thinking out, like, okay, what kind of game do we want to make? What you know, what kind of is it going to be, like a platformer? Do we want to make it like an adventure game? You know, that sort of mindset. So I think I want to say it'd be good, like in the gaming industry, what you have is like a game design manual. And in this manual, you have pretty much everything that's going into your game, like what software you're going to use, what you know, the summary of your game, who it's being created by, you know, what the levels, the like what's, you know, how are you going to score, how are you going to save, just that kind of stuff. So obviously, I don't know about saving because we haven't really got too much into that, and that would be something that we'd have to like extensively kind of look over. But I think the next logical step would be to actually start learning 2D pixel art, and there is this right here, that the ASE ASCII Sprite. Now this, you know, this is a, you know, paid for software. It's, you know, relatively cheap. It's $20, but this will give you everything that you need. It makes, you know, creating images easy, making sprite sheets easy. Um, it makes you know, animations easier. So you can even make layers. It just makes it a lot more smooth for you to do. And there's a trial version, and then you can buy it. There's also you know, free Sprite. So I can actually look right here. Free Sprite tool software, which you can use for PC, or, you know, you can use for your tablets or stuff like there, and you can email it to yourself, and you can you know, slowly start gathering up there if that's what you feel like doing. But for at least for PC, you have this list right here on Felgo. They've put a really good article on many different free applications that you can use, or just ones that you can use in general. So, but these ones right here are free. You can use other lists to find like better ones, but this one, like, you know, if you can't pay that amount, you can use these softwares. And some of the general principles that we'll be learning in the other videos, in the video, well, I should say the videos coming up, you'll be able to do kind of the same effects. There will be slight differences, but, you know, it's mainly almost all the same. Like whenever you're designing pixel art, you definitely want to use a PNG instead of a JPEG. As you can see right here, it's a lot more smooth. There's a lot less noise. While on the JPEG, you just get all this extra noise on here that isn't worth having. It just kind of makes it look like a mess. But yeah, on here it pretty much goes over the basics of sprites. Nah, I don't need that. But yeah, it just kind of goes over the little things, why you should use sprites. And then see, you have Pixel App, you can use Pixie, Pixlr, you got Graph X2. GIMP is a really good, you know, open source software that is just amazing, like just as good as ASCII Sprite. The only difference, it has kind of like a steeper learning curve. Like it takes a while for you to kind of grasp because it has so many tools and different things. So you can, you know, even look at that on YouTube if you need to. But I will probably in the next one, I might actually, in the next session, I'll go ahead and post maybe this link, because we're probably going to go over this a lot more. But yeah, if you can, I would definitely recommend starting getting ASCII Sprite, because that is what we're going to be learning off of. Like I said, you could still use your other softwares that are free, but this is a relatively easier tool to use, and there's a lot more I should say, of a better user base and feedback for this software. All right, so you know, congratulations. So a bit of a preview. I do already have someone in mind that I think would be perfect for being able to teach, and as he right, and the person who does these tutorials would be right here. It would be Saltoons. He has really good a really good tutorial on how, you know, to do like basic designs, and we'll follow along with him. And then he also has like an animation tutorial on how to make things animate. And then you have some of these other ones, you know, beginner to pro, you know, pixel art character design. See, there's another one by Saltoons, where you have, you know, if you're making character design tutorials, you can follow along on here. So I think we'll start maybe doing the ASCII tutorial for beginners. It's about 23 minutes long. There's some pauses in there that allow us to, you know, begin working on our own. And while I'm working on these, you know, you're more than welcome to work on your own. You can pause, you know, the stream, or you know, you can still continue to stream and just, you know, go at your own pace. But you know, we'll do that one. We'll do an animate, and at least get kind of those. I would say at least get kind of those two down, so that way we can like animate, and we can at least get like kind of the basics, and then we can start developing kind of like our sprites, and then going um, into the game development using, you know, tools that I'll provide to you. We'll be using Visual Code, and we'll be using, you know, which I will show you how to download. It's really not that hard. And I believe there is a tutorial for as well for to getting that all set up as well if you want. So it would probably help. Where is it? Right here. So basically, at least getting our things set up by Luis Zuno. So let's go ahead and try to kind of look. Now, if you look at this, there's not going to be a lot of talking or anything in here in these ones. It'll just mostly be just kind of following along, you know, step by step. So basically, the only thing that we would really want to do is the one thing that we would really want to do is just kind of set it up. We want to set our default, you know, screen up, because we've already figured out how to, you know, all this stuff through Codecademy. The only thing we need to do is being able to set it up in Visual Studio Code. I believe it really isn't that hard. Yeah, so you have your doc type, your head. Okay. So I believe we might not even need to Well, we'll probably still need the phaser min.js to get that JavaScript file. Now, because of the web server, we don't really have to do that. I have a local server that we can run things on. I will show you how to do that. There's an extensions on there to actually make it. But technically, you can reach out and you could get WAMP, WAMP server, and you can run your game off of there. But we don't have to get all this kind of software. It just creates the local, kind of a local host on your system. But if we're using a live server that's already made through Visual Studio Code, then that takes out a good chunk of having to set up. But I mean, we could download it and stuff at a later time. Like if you want to actually start publishing your stuff on your own servers and stuff like that, I mean, you can do it that way. But usually you can push all of our finished stuff to like GitHub, and from GitHub you can make pull requests. Other people can like try working on your game and putting all your assets in there and just building up kind of like a portfolio. So anyway, I think that'll be it for today. I will see you guys in the next video, and I appreciate you guys all sticking with me. And all right, I look forward to the next set of learning. All right, you guys have a good night.